Good morning, guys. Starting a bit earlier today as I have a wedding a bit later, so I have to go and fulfill my duties as a friend. Um, let's start. We have a couple of tasks today. Let me just first share the stream with the good people of Discord. Live link. Let me just share it. Whoops. And open NLLB. Started the stream. Okay. Let's wait for people to join. As I said, a couple of tasks today in this stream. Let's focus on adding the NLLB support, internalizing the data distribution, i.e. just getting some feeling for the primary data we currently have, and then going through filtering stage and understanding the details there. Why we get a discrepancy, debugging those parts, understanding whether certain parts are non-deterministic or what's the thing there, what's the deal. Okay, let's open up the download Perl corpora script, and let's go and download. Let's add a function for downloading NLLB Seed automatically, so that people don't have to. So you can just come and run the download script and just be ready with everything. So here we have like what, 30 something datasets or something here currently being downloaded. Let's just add the NLLB Seed. If I open up, if I open up this number of selected items, 36 here, and in dataset 2, 37. So that's exactly the differences that we have NLLB Seed. So let me open up. Good morning, Luca. Welcome to the stream. I think you're one of the first people. Let me open up the NLLB Seed. Let me just find where is our data. Okay, here is the data. The script is provided for convenience to automate the download of many publicly available sources of empty data which were used to train the systems. Usage is as follows. Okay. And here's the NLLB Seed. It can be downloaded from here. Let's go there. Set of professionally translated sentences in the Wikipedia domain. Sample from the list of articles. 6,000 sentences in 39 languages. Meant to be used for training. And can be downloaded here. Okay, so let me just see if I open up this. Okay, we download it automatically. So we can just do the following. Copy this tiny URL, com NLLB Seed. And let's create an actual function that's going to download NLLB Seed. So let's say download NLLB Seed, pass in directory. Okay, and here we create another download function. Download NLLB Seed. Define, pass in directory, I guess, as usually, and then here is the URL. Okay, let's see how the previous ones looked like. Let's grab one of these that downloaded a zip. Let's just find some inspiration here. Maybe. something like this. Let me see whether zip is mentioned above there. Okay, here is a zip. It's usually a, okay. So I think we can do something like this. We can maybe start like this. Just reuse the functionality. Response and then open join and then write. I think that's the common pattern I'm seeing here. Response and then just join and then just open. Okay, makes sense. Let's copy paste that part here. Corpus name NLLB Seed. And then we have the download URL, which is going to be this. And then let's add some description like this. Just swap it with this particular link. And then we download from that URL. Aborting from NLLB Seed. Otherwise, join. And now let's see, I think the name is gonna be just NLLB Seed here. You're gonna see those details very soon. So we write and then we're gonna extract. Let me just see whether maybe we already, yeah, NLLB Seed, it looks like this. Okay, and then let's see, extract function, extract all or something like that. So after the download, we do this. There is a ton of code we can just reuse. So let's do that. With zip file, extract into the direction directory. Instead of this, let's just extract into the datasets directory. And then we can work our way from there. Okay. Test. Let's comment out all of the other ones. Let's comment out the validate script as well. And let's enter here. Hit run. Create the NLLB seed inside of datasets 4. Here it is, currently empty. We request this. If it's not okay, then we raise error. Otherwise, we continue. Oops, I kind of misspelled it here somewhere. Doesn't matter for now. And then we write. So here is the data, and then we extract. And you can see here now we have, again, one more NLLB seed. And underneath it, we have a ton of languages, which are in the good format. So all of these data sets are already in the good format. And we just need to change the names of the files. That's going to be everything we need to do. So NLLB seed is a fairly simple one to process. So let's just see, instead of the dataset directory, we want to actually extract directly into the directory. Wait just a second. Let me see. So if we were to do this, just directly into directory. In that case, we'd have the required structure, I think. And then we just need to add a to-do, rename the files into corpus name language code. That's it, guys. So let me just fix this typo. Let's delete this. Let's rerun. Okay, get to here. And let's see what happens when we hit extract. So when we hit extract, hopefully we're gonna fill in this. Okay, actually not. Actually we create yet another directory. I'm not sure how these two can coexist. Oh, because they have a different name now. It's one is using dash, one is using the underscore. Let's fix that. So one is using dash, one is using the underscore. All of the other datasets are using different format, but it doesn't matter. Okay, let's do it like this. Again, I'm gonna remove these two, move to trash, and rerun. Here we are. So now in expectation, this is gonna be filled by the datasets. And so it is. Okay, that's the first step. The second step will be to, of course, do OS remove of the download path. And also to iterate through the files. Root directory, we don't care about this. Files in OS walk, we walk through the directory. Let's first delete the zip file. Okay, so we walk through the directory. Actually, we walk through dataset directory, and we go through the files. The file name is already the suffix, so what we do is we just go and rename. So new file name is going to be precise f string. It's going to be the corpus name followed by the current file name, because the current file name is literally just PCP47 code. As you can see here, it's just PCP47 code. We just need to assert, let's just assert that the file name matches the regex. Okay, new file name is this. And then we do the renaming of what? Of root directory file name into root directory new file name. And that's it, guys. After this, we are finished. This should be all that we need. I'm going to again stop the run, kick it off again, and let's test it. So again, we extract into this, we remove the zip, and we go through the files, and then we rename to this new file format and hit F5. And guys, we're done. Here it is. Beautiful. Precisely what we wanted. That's it. Let me uncomment all of this, and let me rerun with Let me just rerun the validate script, make sure this is good. Hello, Marcelo. Is it a Spanish name or take rest, bro? You look tired. I just woke up. All is good. And even if I was tired, just because you're tired doesn't mean you should stop. That's not the mentality here. Unless you're really tired. Okay. Just when I wake up, my eyes look like I'm still sleeping or sleepy. Let us check this in. Navigate to the root of fairsec. Copy path. Okay. Git status. Git add this, and then bunch of YAML files, and then okay. So let's just commit. Add support for automatic download of NLLB Seed, and then actually, okay, it doesn't matter. That's fine. Let's just first do one more change. Now that we have all of this done for us directly in the download script, we can deprecate the previous script I wrote, which was super messy because it had a ton of edge cases, which was this one, modify dataset structure. Let me just write something here. This script has been deprecated. Use download parallel corpora by instead. Let me move this comment to the download script here. Okay. Looking good, just left it to do there. Again, going to this script. Let me think. Just reading my own notes. Some days are ambiguous, like beyond it, because it uses which stands for Kurdish, which has 3 specific languages. Okay. Sounds good. Let me just check a couple of things. Language code mappings. Let me see here. Okay, this function should be good. We grab the length suffix depending on whether we're dealing with gzip or not. And then if it's unsupported, we continue. We should not enter here. Okay. Let's move up. Ambiguous, unsupported. This is good and this is good, that much I know. And then I added some of them. Let me see how big is this one. What's the number of, how many did we add and whether that corresponds to the all of the comments. So let's just see print length of the keys of this guy. Okay, let's just put the breakpoint here, and let's run the script. 208, which means we added 6 mappings. Let's just see whether that corresponds to 6 comments. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11 minus the duplicates, which is 6. So that's 5. Something doesn't add up here. Let me just understand. Which one did I add? Do we ever use Southern Uzbek? Okay, just a second. Need to make sure that these mappings won't bite us in the tongue later. Let's run this one. Let's just run this function. Hit run. Hit F5. Hit F5 again. Split. Go and append. And just dump this file. Okay, here it is. I'm gonna make a Python script out of this one quickly. Temporary object. Let's just count the number of keys. Print length of keys. Let's see what we get here. Whoops. Stop this function and rerun this one. We get 196 here. Yet up there in this dictionary we have much more. So let's see what's the difference. Which keys did I add? Let's just see what's the diff between the keys. Okay. Let's just call it temp2. We get the keys 1. And we get the keys 2. and we do the diff let us see. Why is this not working? Empty set. Maybe what we really want to do is set of keys 2, and then difference between set of key 1s. Keys. Let's see this one. Okay, that looks good. Run. So here are some of the ones I've added myself. 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's copy this. Let's quickly go back to the mappings. Let's just add this one and let's see which ones we have commented. So for Arabic, we have a comment manually added after analyzing Tico and seeing their README. I don't think we need to add these anymore, by the way, because now Tico itself will take care that we do the right mapping. So if we go here, let's go to download Tico, enter into the definition, and here, if we find error, just a second, guys, coming back in a sec. Okay. Luca is writing something. Let me see. Yes. Yeah, no worries. Take care, Luca. See you later. Debugging is super important. Otherwise, I mean, you have to somehow understand your code, either through stepping through or looking at logs. But this is definitely the best way if you can afford it. Okay. Let me quickly check a couple of things here. So we map using this, and then we call convert into this. ISO to BCP. So if the language code turns out to be ARA, then we'll just return it here. It doesn't match. It's not this edge case. It's not ambiguous, or it is. No, it's not. It's not unsupported, which means we're gonna map it using this. Okay, so we make some assumptions. See? Okay. Just last checks before we continue on to analyzing the data, just to make sure I didn't make any stupid mistake here by assuming these mappings. ARA. Let me close down this one. We don't care about that one. Let's put this on the right. Let's open up the download script. So the only place where we have ER is here in the Tico dataset. And we do handle that case, so we're good. This one is gonna get filtered out. So that means this one doesn't have to have, we always map to Ethiopian script. Okay, I can remove this one. We make an assumption. Which specific lengths they map to. For this one, all is good. Let's continue analyzing the rest. POS maps to we only have Southern Pashto. Let's just double check we only have Southern Pashto. Pashto dataset, Pashto language, only Southern Pashto is available, okay? Let us continue. Okay, this one is fairly unambiguous because we only have Southern Pashtos among supported datasets. And then ORM. Same thing here. And then let's see for GAG. It maps into this language. As long as I have some comments, they'll help me get some confidence we didn't mess up. ARA. Looking good. Ori. Do we only have this single variant? Let's see. Good morning, SQ. Welcome to the stream, man. We only have audio. Okay. And then we have Azerbaijani. Okay, we have a comment down below. And then MSA. So this is again Tico. We make an assumption, but we note it clearly. And then Uzbek. Okay. And then let's see 3 more codes. to check. Let's see, din. Okay. Again, din is a macro language, I think. Din stands for, oh, din doesn't even have a, din might be one of these macro languages. Let's see which one. So din, wait, why don't we have din anywhere? Oh, it's mapped to this southwestern Dinka. Maybe we have Dinka. South Sudan. Why did we make that connection? Somewhere here, it's hidden. Venda. That's Uzbek apparently. Sardinian, certainly not there. Persian, it might be Persian. No, this is Dari and Pashto. Oriya. Nepali. Malay. Dinka. Name of macro language. List of macro languages. Oh my, we had the macro languages here. I should have opened up this before. Okay. Spoken by only 1.3 million people. And as you can see here, there is a ton of these different ones that we have, and we are just using Southwestern Dinka. Okay. Left a comment there. Finally, we have Kurdish. And at the end, we have Farsi. Okay. Because Farsi, if we find Farsi, it consists of Dari, PES, and PRS. One is, I think, Arabic, and the other one is not. Or no, both are Arabic. Wait. Okay. That's it. So these are some additional macro languages that we've added. And now we can submit everything and just continue. So let me delete this script. Move to trash. Let's go here. Let's delete a couple of things I wrote down here, like this print statement. And let's delete this call and let's comment this out. Let's see what the changes are. Okay. Couple of comments were being updated here. That's all good and fine. Okay. Add this. Add the mappings. Oops. Click add, and finally add the modifications of this script. Oops. Looking good. Anything else? Nope. Everything else is just a YAML file. The last thing is to change the README. So run the script, see below. And then step number 2, use stops to filter and prepare the data. All primary data plus NLLB Seed. And then we can use stops. Done. Just add the README. Add the examples README. And commit. Let's push this to our repo and let us continue. Now we are done. Now that we are done with that part, let's quickly analyze the data, and then let's go to the filtering stage. So analyze data script. I'm gonna open it up here. And let us analyze all of these three for which languages. Maybe the duplication, we don't care about it for now. Line lengths are useful. If we don't specify anything for languages, what will happen? Let me see. Line lengths. Okay. Let's get some insights. Let's print all of the data sets. So let's add some special codes. So if it's none, then we just go and specify everything. If it's none, okay, looking good. We can just specify none here. And then we'll compute every single line for every language. It might take a while. So maybe better to first just run the number of sentences. Let's stop here. Running. Okay, I ran with the wrong set of arguments. Let's just set no arguments and now kick it off again. Actually, sorry. We have to use the analyze data script. Config. Okay, we're counting lines for each of the files in our data. In total, 722 files apparently. That's because we are not using the latest. Let's see if we specify in the long JSON analyze data. Let's specify not filter out, but instead let's specify this path, and let's change suffix to 4 because that's the latest data set we have. That's the one we just prepared. And then we're gonna say, no, this is not gzip. So we can stop this run. We can say verbose, and everything else remains the same. Analyze data. Kick off the run again. $726 files. Let me just check. If we move out NLLB Seed, something's weird. I would expect more files. So if we go to here, if we just move NLLB Seed, just make a cut here and copy it here, then what number of files will we find now? 726. Let's kick off analyze data. Okay, 648. That makes sense. Let's retrieve back NLLB Seed, cut, and paste to datasets 4. Exactly. Rerun. Okay, we're here. One last thing I want to check is why is this not printing? Let's print stuff. Language code suffix. Unsupported suffix or not the language file. So if we hit here, it's unsupported. If we hit here, we're skipping because it's not a language file. Exception, otherwise it's good. Let's rerun and see whether we hit any of those branches. Okay. We are not hitting anything. Just counting lines. Counting lines, no other message on the console, which is actually good. Okay, so we found 94 languages again. That many sentences. Let me see whether that is the same number as before. Did I note that somewhere before? 94. Yes, here it is. 279, 627, 692. We have more now than before. Interesting. And let's see number of directions, 213. So we included 2 files additionally, two directions. So that means that my modification of the download scripts worked because we apparently had some smaller issue and we were filtering out certain language directions, which we are not doing anymore. So that's good. And now we dump this and we go and visualize this. So we grab the number of sentences and number of directions. We plot the log values. Let's just see how this looks like. So here are our data sets. For different languages, the number of sentences on a log scale. Again, the biggest ones are Russian Cyrillic, English, and Turkish. And then this one here is what? Kazakh language. Interesting. Okay. Let's close this. Let's see directions. Obviously the x-axis is kind of a mess because we have 230 language directions. You can maybe see which are the biggest ones by zipping these two and finding the So we can do something like this. Create a list. It's gonna zip these two. And then we wanna sort it such that the key is actually the log value, and we sort in reverse, and we just print first 5 elements. Or 10 elements. Okay, I think we can do that now in the terminal as well, without having to rerun. We just do that. Debug Console, key log values, print the first 5 elements, and we can see here that English, Turkish, Russian, Turkish, Russian, KAZ. Let me just double check which language is that. KAZ is KAZ, Kazakh. Kazakh language. Spoken Turkish language, Central Asia by Kazakhs. Interesting that that's one of the most spoken languages in our corpus. Russian, UZN, and English, Hindi. Interesting. If we were to do the same logic but just for languages, let's see what are the top 5 languages. Let's run this again. Just this time we specify, instead of language dictionary, we specify this particular one, and we specify its log values as well. And let's see the first 5 elements: Turkish, English, Russian, Kazakh, and UZN. What's UZN? UZN, not mentioned there. UZN, Northern Uzbek. Wow. Maybe we can do without log values. Let's do the same thing just without log. Okay, here's the actual number of sentences. So 5 million sentences for that language, 10 million for Kazakh, 4.4 for Russian, 8.7 for English, and 10 for Turkish. Or no, 104. Wow, that's a ton of sentences for Turkish. Okay, now let us enable feature type, line lengths. This might take a while to run this one. Line lengths. If line length is specified, then we will be hitting this, which means we'll be hitting this function, analyzing, opening up the files, reading the actual lines, and then because we are verbose mode, we'll be printing the outliers. Okay, looking good. This file might be over a gigabyte in size because we're going through the whole corpus. Okay, we are done with that. We are now doing this, and next step is this one. Guys, for those of you who are new to the stream, check out the Open NLLB channel. That's where we are collaborating together. And see the pinned messages here. Sign up for the Language Champions doc. Let me see whether some other people suggested new changes. Okay, let's see. Mohammed apparently speaks Bengali as well. And then we have Nepalese. Nice. We have a lot of languages that I've never heard of. Which is cool. Maybe we can start sorting them according to geographical regions. Becoming hard to wait, who is this? Is this Amrit's LinkedIn? I'm not sure. It's becoming a bit messy. We have to clear this up a bit. Maybe we can organize this by languages a bit. German, European languages. Okay, here we are here. Let's see. Again, same numbers there. Now for the language features. Okay, we start with first language. Chinese. Max elements. Number of outliers. Let me put a breakpoint if the number of outliers, if this relative number is bigger than like 0.1. So you can do this if you didn't know, guys. Go and edit breakpoint and then put a statement like if this is bigger than let's say 0.01 or even 0.01, I want you to hit that breakpoint. Here is the distribution of line lengths for Chinese. Let's continue. Next up, English. Okay, 0.001. So there is a ton of outliers, 93 sentences. Wow, some of these are fairly long. There is one that's, let me see, around 1,000 characters. Actually more, wait, I'm not looking at the right numbers. 47,000, 50,000, 60,000. Okay, something is off with a couple of these sentences. Let's see how English looks like. So here is English. And the plot is very weird because, as you can see, on the x-axis there are some outliers that are huge. And so this collapses into like a Dirac impulse here at 0, seemingly at 0. So it would be worth a while to analyze what are those outliers. So let's analyze, let's edit to do, analyze the longest lines in English. So this is KMR. So this is how normal distribution looks like. Whereas English was completely messed up. Let's continue. Let's just put a breakpoint here. No, 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 stop there. Okay. Let's plot this. Again, there are some huge outliers here. We're gonna check what's going on there. This was Turkish. Let's continue. Next up, this one also has unusual outliers. Malin. Okay, let's continue. Oh, this one has a lot of outliers. 0.02 in Hindi. 2% of data are outliers. I think we did, okay, we did analyze Hindi already. It turns out those are some religious scriptures from Wikipedia. Amrit helped us figure that out. This is Tamil. Tamil also has weird outliers. So we'll have to check those. Those might be coming from the same types of sources, because obviously this is a parallel corpus. So if English has it, maybe also Tamil has it because they come from the same data set. And then if one is big, then the other one is big because they're translations, they are coupled. Underscore Tamil. Let's go. F5. This one as well. MAR Deva. F5. Okay, most of them have some weird plots. Ben Bengali. Bang. Hit F5. Let's see this one. Telugu as well. Again, by analyzing a couple of them, we'll probably figure out all of them. Hit F5. Okay, this one has a lot of outliers because we've hit this conditional breakpoint. Over 1%. This plot actually looks nice. No significant outliers. Hit F5. Again, a lot of outliers in, what is this? GRN Latin. Distribution looks normal other than these couple of peaks in the beginning. Okay. Those will probably get filtered out by our length filter. This one looks reasonable as well. What language is this? That was Lin Latin. This one has a lot of outliers, 15%, 1.5%. But the distribution looks fairly healthy. This one is looking, wow, what is this? Look at this. Interesting. It's like skips certain line lengths. Let's analyze this one. Has a very weird pattern. AKA Latin. Choppy pattern. Hit F5. This one looks healthy. This is Zulu. Hit F5. This one, again, huge outliers. Pan Guru. Hitting F5 again. Running the next language. This one looks reasonable. This is again very much skewed. Canada. Hitting F5 again. Whoa, this is interesting. Again, very irregular patterns here. One would not expect this from humans. What language is that? MRI Latin. Choppy pattern. That's why this analysis is super valuable, to understand the patterns for each of the languages when it comes to line lengths by seeing the distributions. Okay, this one, again, a couple of these super nicely spaced out patterns. I'm not sure why we are seeing those. So let's just add that one as well. So maybe we can lump them together into the ones that have choppy patterns and the ones that have very much big outliers. Okay, let's keep on collecting that list. Hit F5. Okay, very noisy, but we can ignore this one for now. Wow, again, weird patterns. Yes, Arab. Hit F5. Looking good. Choppy. Hit F5. Choppy as well. Hit F5. Choppy as well. Next language. Whoops, I missed this one. Accidentally skipped over the F5. This one looks healthy. Most of them were weird, including this one, choppy. ARZ, Arab. Mostly Arab. This one looks good. Very much choppy. This one looks healthy. A couple of longer outliers, but nothing significant. Same here. Same here. Same here. This one is choppy. TZM TFNG. Wow, that's a mouthful. TZM TFNG. This one looks healthy. This one has patterns. MNI Bang. MNI Bang. Choppy, HNE Deva, HNE Deva, F5, next language, looking healthy, looking healthy, looking healthy. I don't think we have too many more. This one, choppy, bug. It's a bug, man. Bug Latin. Finally, a very descriptive name for a language that has problems. Bug Latin. Choppy one. LMO. Laughing. Yes. YouTube will ban me. LMO Latin. Next language. Choppy, very much. BHO Deva. BHO Deva. BHO Deva. Looking healthy. Looking healthy. Healthy as well. Choppy. LIM Latin. Okay. Healthy. Healthy as well. Healthy as well. Healthy as well with some peak in the beginning. Where is that peak? That peak is around. Yeah, I should have made an interactive plot, but this is just good for initial exploration. Okay, this one is healthy. Healthy as well. Healthy as well. Healthy as well. Okay, this one is weird. This one is very, very weird. AFR Latin. Why do we have this language? AFR, wasn't that? Shouldn't that be filtered out? Oh no, that's a different one. AFR Latin. Very weird. Let's continue. I don't think we have too many more. Wow, this one is also super weird. SSW Latin. SSW Latin. SSW Latin. TSO Latin, same here. They are probably a part of the same corpus, because they all look very suspicious. Let me put them literally on a separate line, or somehow isolate them because they are different. Hit F5. Again, this one, TSN Latin. I'm fairly sure they are part of the same corpus, and so that's why they all look alike. State-of-the-art language, SOTA Latin. We had the bug, we had the SOTA, everything is there. What else do you need? Iwi Latin, choppy. And this one has a lot of outliers, 6%. Interesting. Okay, definitely weird. Looks like a dampening function. FON Latin. Looking healthy. Fairly healthy as well. There are some outliers. Okay, this one has a bit more than 1%. That's cool. But it's fairly choppy. So let's add it. Haitian Latin. Healthy. Indonesian. 3% outliers. Chinese. Looking good. Looking good. That was modern, standard, or epic. Looking good as well. Portuguese. Looking good as well. Khmer. Looking good. Good. Okay, Russian Cyrillic. Again, these are 30,000. All of these are related, probably part of the same corpus. Russian Cyrillic. Looking good. Looking good as well. Looking good. Looks good as well. We should be almost done because we went through almost 90 languages. We have, I think, around 94. Looking good. Good as well. Good. Good as well. A bit longer, but not that significant. Good. Good. Okay, this one is a bit Turkish Latin, a bit more around 4K. Okay, this one is okay. This one is similarly 3K. And that's why you want to always have progress printed out. I have no idea where we stand with the number of languages we process, but I'm fairly sure we're at the end. Can we do something like length of keys and then maybe like index of lang? Convert to list. Will that preserve the order? I'm not sure. Worth a try. 91. We might be at the end. We might be at the very end. Just when I thought this is not ending. Okay, there is a UZN Latin. That's one of our most one of the richest languages when it comes to number of sentences. So I guess it's connected to some of the other corpora. Looking good. And we're done. And next up, we just print the languages, number of sentences, log scale. Okay, that's it. So now that we've processed this, we have some lists. Let's just try and do this one. I've skipped it, so let me just add it in particular. Oops. Let's see what was up with that language. Rerun just with that single language. Next up, we're gonna dig through the files and see how they look like. Why do we get the choppy ones? Why do we get the outliers? Vector Latin, let's see what is up with this one. 0 outliers, interesting. And it looks very reasonable. With that, we are done. And then we have a couple of classes of languages. We have the very weird ones. But not because of length, instead because of choppiness. We have the choppy ones, and then we have the big outliers. So let us analyze these languages. Get some feeling for the data, and then continue on to the filtering stage. So let's start with Afrikaans, I guess this is it, with the Latin script. How can we find, let's skim through the, let's create another script quickly. Whoops. Temporary pi. Print them here. Copy the path of the root. And then just walk through the root. And then we want to call our filtering function, which is called retrieve supported files. It's imported. Okay. Something like that to get the file names. And if we go through the files, we grab the suffix, and we just ask if the suffix equals our target language. If it does, print the whole path. That's it. Let's see which files have Afrikaans. Oops. So here is the list of files that have Afrikaans, just a single one, just a single data set. Muburisano. This one. So this one had a very, very choppy pattern. Let's see why. Okay, because there are some sentences, as you can see here, which differ in only a couple of words, and they come in blocks. Huh. Okay. We don't have too many sentences. Only 283 sentences here. And a lot of repetitive ones. Okay, so that's the issue. When we were analyzing this, what was the length? Let me rerun the analyze script with Afrikaans. And let's go to number of sentences, just to see how many sentences we have. Is it really 230? Just to double check here. Okay. Yes, 283 only. And we just saw it above as well. Interesting. $283 only. Okay, so that's the explanation. Not that many sentences. A lot of them are very repetitive with just some small variations. That's why we have weird . On our primary training data, we only have 283 sentences. Line length. That helped me find certain outlier languages. Plus it's very choppy, meaning a lot of sentences of the exact same length repeating with small variations. Okay, let's go SSV Latin. Let's see this one. Let's run it. So this one is, again, same data set. So I assume it's going to have very similar patterns. All of these four are probably going to be in the same data set. SSW. Here it is. Here it is. Again, literally the same pattern because they are translations. And then TSO Latin. Let's see this one. Again, same data set. Surprise, surprise. And you can see here, all of those are here. TSO, TSN, SOT, TSN, SOT, SOT, TSN, TSO. All of them are the same, so we don't have to analyze them. They are all a part of the same, data set. Emburisano. Okay. Choppy pattern. Let's go for AKA Latin. Let's run this. That was fast. We went through the very weird ones very fast because they're all part of the same data set. Here as well, Aquapem data set. Aquapem. Let me just delete these two. Aquapem. Okay, we just have repetitive directions. We can just check one. Okay, this one was choppy. Okay. Looks reasonable. I'm also using this on the right hand side of the screen. I don't know if you can see it. VS Code has a small preview so I can analyze almost like a histogram the sentences. So why is this one choppy? Because I don't notice anything weird about the actual corpus other than the sentences are all very, very short. We don't have any super long sentence. Very simple sentences. Okay, let's continue. MRI. Magnetic resonance. Okay, this one is in NLLB Seed. So that might mean that we will have a lot of these being translations of one of each other, the ones with choppy patterns. Let's go to English Latin, MRI Latin, English Latin, MRI Latin, this one. Let's open it up. So this one is apparently very choppy. Okay, that's because every now and then we have this similar pattern. They might be duplicates, by the way. So this one, Ahuwanui. Interesting. This one has much longer sentences compared to the previous dataset we saw. Okay. Super fun how you can notice certain patterns by just analyzing the data using histograms or whatnot. Okay, that was fun. So then I assume a lot of these are going to be the same insights. Go to temporary, so MRI. This one is going to be probably also just NLLB Seed, in which case we can probably skip it. It is. Let's just double check. I can actually, wow, nice. I can open up the dataset directly through the command line. That's cool. Again, I think this is the same pattern as before. Yeah, same type of text corpus. Let's go to the next one. KAS Arab. I wouldn't be surprised if it's the same dataset again. And it is. NLLB Seed. Let's go to the next one. TAQ Latin. Running again, expecting the same NLLB Seed, and it is. Let's go back. Magdeva. Let's see whether this is the same as well. And it is. So these are just parallel translation, like n-way parallel. BJN Arab. This one might be different. I remember it had some weird pattern. No, it's the same. Okay. I love the Arabic scripture for some reason. It's very nice. There is something beautiful about it. I guess because it's different compared to Latin. All of the other languages are fairly similar with Latin script. ARZ Arab. Let's kick it off. Let's see where it is. Again, same dataset. ARI Arab. Again, same dataset. And then PZM. PFNG. Wow, look at this script. This is also fun. Looks a bit like Greek. Interesting. Imagine if the Western world in a parallel universe used this type of script. That would be fun. Back to here. That was TSM, MNI Bengali. Run. Again, most of these come from literally the same NLLB Seed dataset. Hindi Deva, or no, this is HNE Deva. I'm not sure what this is. This one is also an interesting script. Bug Latin. Let's see that one. I want to see how bug looks like. Okay. Boring Latin script. LMO Latin. Again, same dataset, boring Latin script. LMO Latin. PHO Deba. Rerun. Same dataset. PHO Deva. Lim Latin. Same. And then EV Latin. This one might be different. Okay, and it is. This one was also choppy for some reason. I'm not sure why. Let's see, going down there. Okay. Seems like it's all around the place. I would never have guessed. Okay, there are these parts that are very short. Looks very reasonable. And then finally a couple more here. EV Latin, FON Latin. Let's run it. Okay, this one has two. FON Latin here. Again, reasonable. Okay, this is weird. Very, very short. Parts with just single words. That's definitely weird. Okay, very, 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 very short. This one is very weird. Okay, so this one is worth mentioning. Let me just copy this one and mention it. So these two stand out so far. The ones that stand out are truly Afrikaans Latin because super short, only 238 sentences. And then there's the FON Latin, FFR dataset. Ton of single word sentences. Let's see the other dataset. Is it the same thing? A bit longer, but still very short in general. Okay. Let's go to the last one from the choppy category, Haitian. Run. Here's the Haitian language. Doesn't look too awkward. There's some repetitions. It's not very long, just 1,600 sentences. Some repetitions. Very repetitive. That's the conclusion there, but okay. And finally to the last category, big outliers. So let's start with some of these that are not as, these are the biggest ones, right? We have the most sentences for these languages, and Russian as well. Russian. To analyze these, we'll really need to go to our previous analyzed script and see the actual sentences instead of, because we're looking for big outliers, right? It's gonna be hard to find those by just going through files. Might be easier to have a bit different approach. So let's start with, let me copy these. Let me maybe copy this whole thing to the notes on languages. Line length analysis of the primary data set. Some outlier languages. very weird copy patterns, looking at line length histograms. All part of the same data set. Copy pattern. Most of these are part of the same n-way parallel corpus in NLLB Seed. And finally, the big outliers. Okay. More. Okay. And finally, we have big outliers. $10K plus line length. Okay. By analyzing them manually, I found these two outliers that stick out even more. One is African Latin because super short, only 200, super small corpus, only 238 sentences, and this one is weird because it had a bunch of single word sentences. Okay, let's close up these ones. And let's go and again copy these, come back to analyze data, and let's analyze these languages. Let's start with Turkish Latin. This is not Turkey, this is TUK. I'm not sure which one is it. Okay, let's run it. Kick off the run. And we want to see when this is above, let's say we want to see all of them that are above 3,500 or 3,000 characters. And let's put a breakpoint and let's run. Here's the first one that's super long. Let's see how it looks like. With length 4,000 something. In here, 60,000. This is the ID. This is the row of the sentence. Let's open it up. Let's see whether I can go to this line. Okay. Whoops. Go here. Is that the long sentence? It is. Look at this. Look at this. So let me think. We want to keep this data. We want to just split it somehow and not lose this data, but we need somebody to analyze what this is. These outliers need to be analyzed, and that's where we need the language champions. We can maybe create it as a task for language champions or something. We can create tasks which they can analyze. Okay, interesting. That was very interesting. Let me think for a second. What should we do with this? I think I'm gonna paste this to the language champion document as a task. Let me think for a second. The other groups. Okay. I'm gonna definitely grab this sentence and paste it. Let's paste it here. Is a single sentence in which language is this again? TUK Turkmen. Let's go here. Man. Okay. Let's continue. Those are some types of tasks that we can give to people. Let's continue. Similarly, 9913. Okay. Same here. Whoops. Let's go back. Hit F5. There is one more. Again, some long sentence here. Oh, this looks very similar. This is probably just a duplicate. Let's come. Yeah, this is a same sentence. And this is also actually same sentence. So this text here looks to be the same here and here. Okay, these are actually just duplicates. That makes sense. They were all of similar length. I was suspicious. One more, again, very similar length. Very similar sentence. Hit F5. And we are almost done. Nice. How many sentences does this language have? No. Yes, 1 million, 1.5 million sentences. Cool. That was the first outlier. TUK Latin. I mentioned it here. Okay. Let's continue. Started adding language champion tasks to our document. Added some long pieces of text in Turkmen language. I think that was the Turkmen language. Was it Turkmen? Hello folks, it's Ahmed Shapiro, NLP R&D engineer at Georgia Tech. Nice. Nice, amazing. We really need people like this. For start, check out the pinned docs, and we can jump on a call over the next few days to discuss the progress, the plan, and the best way to collaborate. Okay, guys, let's continue. Let's go to the second language. Let's go and analyze. I think this is Kannada language, which is just some, I think it's some Indian language, yeah, Indic language. So let's put the breakpoint here. We have a breakpoint for over 3,000. We're gonna grab those. Maybe for start, let's just see what are the longest. Before we go there, let's see what are the longest sentences, so we can set the threshold. So that we can set the threshold for this particular language. Because if many of them are over 5,000, we don't want to grab every single sentence. Okay, doesn't seem there are too many outliers. So far, so good. Okay. The maximum ones are, okay, so there is a single one that's like 10,000 and one more that's like 7,000. So that's those are the outliers. So let's just put the threshold to like 7K here. 7,000, and let's rerun with a breakpoint there. Okay, let's grab those two sentences in this language. So sentence number this in this file. So let's just go there. Whoops. Let's just go there. Here it is. Looks like a long sentence, and it is. Let's just copy it. And let's go to our language champions document. And let's add the task. The following is the sentence in a language called this. Let's see what's the, okay, this is the name of the language. Kannada. Okay. Turkmen and Canada. Can we put some horizontal line here or something? Is there any way to insert a horizontal line? Okay, something like this, just to make it a bit easier to parse that. Let's continue. Let's grab that second sentence. Go here, hit F5. Here's the second sentence with the length 10,000. My God. Copy this line row and let's go there. Here is that sentence, again, super long. Let's just do it like this. Copy the piece of text and go to this document and paste that second thing here. Okay, there is some weirdness apparently going on here. Some weirdness. Okay, let me... It was a bad idea to just post this without separating it somehow. Okay. Looking good. And the previous one was this. Okay. Let's continue, guys. If we hit F5, I'm sure we will not hit any other exception. I mean, outlier. So we can continue to the next language. Let's go to Panguru. Again, before setting the threshold, let's see how many of them are the outliers. Let's run. Let's find the outliers. Max 10 elements are what? Okay, there is one with 10,000, there is one with 2,000. Let's put it to 2,000 just to grab the top two outliers in this language. Let's put the breakpoint here and let's rerun. Okay, first one, length 10,000. This is the line number, and let's go to the file. Let's find that line number. Here it is. And again, it's a super long sentence. So let's see, let's copy it. Let's go to our language champions doc. Let's put here horizontal line. And then let's paste this thingy. Very weird with some characters and stuff. So this language is Panguru. What's that? Which language is fun? Punjabi. Punjabi. Guru. Scripts. Gurmukhi script. Bottom. So we have this Gurmukhi script. Okay. Punjabi language. You can put like smaller titles here. Like heading 2. Just to make it a bit easier for people. Turkmen, Canada. Punjabi. Let's just copy this sentence. Punjabi. Okay. Okay. Let's continue. Hit F5. Let's find that second outlier, which is only around 2000. Only. I think 2000 might be a reasonable sentence, like if somebody's very eloquent. Very, very eloquent. Let's go here. Copy that sentence. Okay, this is a decent, still super long, but why is this a single one? We don't know. That's why people will help us with. Okay. Let's continue. We can stop this one because it will not, okay, as I said, this one doesn't have any more outliers. So we are done with that one. Let's continue to the next one. This one. Telu. Let's see what are some of the insights here? How many outliers do we have in this one? How many outliers? Let me just send an image to my friend. He asked me about where I'm currently at. I'm just taking a photo of my digital dragon rig. Okay. How many outliers here? Wow, okay, 8,000, 9,000, 9,000, 13,000, 13,000. Okay, let's grab the ones above. Let's put 8,000 and then we can find the truly biggest outliers, which are 44,000 and 19,000. 44 and 19. Okay. Put a breakpoint here and kick off the run. Whoops. Stop this one and rerun it. This one is 13,000. Let's copy it. Let's go to the piece of text. Here is that one. Looking weird. So this is a different language. Let's insert a horizontal line. I'm gonna have a task there. Let's first paste it. Okay, there is something weird here with a ton of chemical elements, probably. So this is the language called TEL. Let's see what TEL is about. TEL. Telugu. Telugu language. Okay. Let's just open up the task here. Let's say Telugu. Heading 2. Copy the BCP47 code and make this a task. Like this. And let me just keep this here again. This is heading 2. Telugu. Let's just link that one. Okay, that's Telugu. The above one was Punjabi. Telugu and Punjabi. Punjabi, Telugu. We might have people who already speak Telugu here. Let's see. No, we don't. Punjabi. No, we don't. Not yet. But we'll find them. Let's go back. Hit F5. Next one. 13,000 again. Let's just hit F5. 13,000 again. These are probably similar. This one is length 9,000. A lot of English, as I can tell. Oh my god. This is not a proper text, guys. So we can see some of them that have too much English, we can filter them out based on that criteria. And maybe we'll be able to recover some of the other data. So we'll see what's the best way to process these. Instead of filtering them out, do we want to do something else? Do we want to somehow preserve them? Let's continue. F5. 44,000. This is a big outlier. Let's see what this is. 44,000 for this one. Oh my god. I already see some weird pattern there. Let me open up the doc. Boom. What is this? Looks like a religious text, maybe. And with that, I'm gonna wrap up for Telugu. Insert a horizontal line. Let's go. Let's go back to our analyze script. Let me remove Telugu. Let me put in this Bengali language. Remove the breakpoint and put the breakpoint here and rerun. Let's see what are the outliers. And then we can put a decent threshold and analyze this one. I'll soon have to go for the wedding, guys, but I'll continue streaming afterwards. Okay. How many outliers? 8,000, 8,000, 9,000, 12,000, 12,000, 16,000. Again, this might be... Is this from the same dataset as before? It might be. Telugu before was... Telugu was in Wikimatrix, one of them. And this one is, no, this one is TED. Let's find it. Okay, so we said 8,000. Let's just stop this. Let's go up there. Put this to 8,000. and put a breakpoint here, rerun. Okay, let's see the first outlier, 8,000. Copy this, go to the file, Wikimatrix as well. Aha, so this might be translation. These might be the same sentences. These might be the same sentences. Let's just open up. Okay, let's first go here and copy this. Whoops, let's just copy that piece of text. Again, this is Bengali or something. Let's see. Let us just mark which language that is. That's this one is the code. That's the code. And let's see what's the actual language. BEN, Bengali indeed. It's a Bengali language. I keep on removing this browser tab even though we need it. Let's put this to be heading 2, Bengali, and then let's copy the following sentence and just change this to this and write down Bengali here. Open this up, copy the link, and just link the Bengali. If anybody's curious, we can open up what Bengali is quickly. Okay. Let's continue. Again, Wikimatrix. This one is 8,000 in length. Let's find the one that's 16,000. Let's just put a bit higher threshold. Let's put the threshold of 13,000. And let's rerun it. Okay, this one is 13,000. Second task for Bengali. And then finally, let's kick it off again. Hit F5, there is just a single one more. This one has 16,000. Let's just go here and type in that line number and let's copy this one. Whoops, no, don't do that. Don't ruin the data. That's a bad idea. And third task for Bengali. Let me see whether we mentioned colored somewhere before. Nope, looks like a unique string. Okay. Bengali. I'm gonna stop this one. After we wrap this up, I want to do one more to do. See whether they come from common data sets. Seems like many of the Indian ones come from Wikimatrix. And Wikimatrix is basically a mined data set. So that's probably why we see low quality data there. A ton of noise. Let's go with Mardeva. Let's set the threshold. First to something lower. Let's kick it off just to see remove this breakpoint here. Put the breakpoint here to see the outliers. If we see a similar distribution like 16,000, 8,000, 8,000, then it's obvious it's just a translation of the previous data set we were looking at, previous language, in that same data set, Wikimatrix. Let's see. So again, no, this one is different. 2,000, 2,000, 21,000 for one, 11,000 for, okay, let's put 4,500. That's gonna catch 3 outliers. 4,500. Let's stop this. Let's rerun with a breakpoint here. And let's see. So first one, 21,000 in length. Let's see what's up. This kind of looks similar to one of the previous ones. Let's go to our tasks. Let's insert a new line here. Insert a horizontal line. This language is, I have no idea which one. Let's just see again. Some Indic language as well. Let's see what it is. MAR. Okay. Marathi. It's a Marathi language. Marathi language. Copy here. Make it heading 2. And then copy the above task for Marathi. Marathi. Let's open it up here. Grab the link. Just paste it here. Insert the link. That's Marathi. It's coming from the Wikimatrix again, apparently. So all of the bad ones are from Wikimatrix that come from mining them, I guess. Okay, let's hit F5, find the second one. This one is 4,500 in length. Let's see. Copy it. Again, Wikimatrix. Just find this one and looks very bad. Second one looks like this. Second one. Second task in Marathi. So this is Marathi. Let's go back to our VS Code. Hit F5. The last outlier is 11,000 in length. Again, this is JW dataset. Okay, that might be also mine one. That might also be a mine dataset. Let's grab this. This definitely looks cleaner, but obviously too long. Okay, third task. Okay, something is definitely off here, but looks very similar to some of the previous ones we saw. So let's make this a task. Oops, not that, instead this. Third task for Marathi. Okay. Let's continue. Let's go back to our file here. We can stop this run. Next one is TAM. Let me open up the notes. TAM. Let's see what this one is about. Go back to analyze data. Paste it. Let's find the outliers. Let's reduce this to 2000 for now. Let's remove this breakpoint and let's put the breakpoint there. Looking good. Let's see what the outliers in terms of length are. And then we can estimate what's the required threshold to pick up some weird outliers. Okay, so we have 10,000, 10,000, 10,000, 30,000, 11, 16, 54. Oh my God. 13, 12, 14. Okay, let's go. Let's set it to 16,000. Let's set it to 16,000 and let's rerun with a breakpoint here. First one, the length is 30,000. Interesting. Copy. Let's go to the actual. Okay, again, wiki matrix. We're seeing a pattern here. We're noticing a pattern. Let's just copy this one. So this is which language? Insert a new horizontal line. Okay, a lot of mathematics here apparently. And for some reason, somebody thought this is, oh my God. Yeah, I'm just gonna remove some portions here, just because this is pure mathematics, but leave a piece of it so that they can help us understand it. The maths. Understand the mathematics. Okay, so what's this language? This language is Tamil. Paste without formatting. Let's see what it stands for. Tamil. Let's open it up. Tamil language. Tamil. And then let's make it a heading 2. Whoops, let me select. Put heading 2. Put the link here. Let's just find the actual task. The one we've been copy pasting. So this one, let's go below. And let's go here and just put in Tamil here instead. And let's delete Marathi. This is Tamil. Let me copy this. Let me link it. Insert the actual link. That's Tamil. Okay. Let's go to the second one. 54,000. My God, this must be something completely off. And again, this is Wikimetrics. Okay. Definitely looks gibberish with a lot of numbers. This is just some bad data. So second one. Woofs. This is gonna, okay. There is a ton of, well, actually there is a ton of text as well. This is a long one. Looks like a ton of similar text to me. Oh my God. Okay. We're done there. Let's just hit F5 and see what the, again, Wikimetrics. All of them are from Wikimetrics, and we can now stop because we've got all of the 3 outliers. We can now go to the other ones. Okay, let's go to this one. Again, reduce this to 2000 characters and remove the breakpoint. Let's just see what are the thresholds that we need to set for this language. Okay. Okay, let's see. 2000, 3, 3000, 10,000, 3, 5, 4, 4, 4, 5. Let's set it to 5,000. And then put the breakpoint here and rerun. Okay, 5,000, the first one. Copy the line number. Go here. Grab that piece of text. Interesting script. Open up this. File, insert a horizontal line. Copy this. See which language we are dealing with. Malayalam. Okay, that's again some Indian language, yes. Malayalam. Put that as a heading too. Grab the actual BCP47 code. Whoops. This is the BCP47 code, and then go grab the actual task. Okay, here's the task. In Malayalam language, and let's just grab the language. Let's grab the link here. Let's insert the link. Let's go back here. Let's continue. Grab the line number, enter here. Copy this. Go to second task. But let me just see something. I scheduled a post on LinkedIn, whether that worked. Okay, apparently it did. Okay. Sorry about that small break. Second task. In Malayalam. Going back here. Hitting F5. Let's find the last one. 10,000. Copy the line number, enter the data. Navigate to the line. Copy the actual line. And here is the third. Again, I keep noticing these patterns. This is probably just all from the same data set. This is the third task. Third task. And we're done, guys. This was again in JW, either JW or or Wikimatrix. We can stop this, go to the bottom of the script, remove this language, and now we start. Now we are in the category of these super resourceful or high resource languages. Let's go with English. So for this one, I can fortunately do it myself. I think. Let's go and set this to 2000. Let's just remove the breakpoints so we can see the outliers. I do expect some huge outliers here. Let's just see what are the numbers we are dealing with. There's just a ton of outliers. It's a big language. Okay. Almost there. English is a bit slower. I'll be wrapping up in 10-15 minutes, guys. I'll have to go to the wedding and then we can continue afterwards. Okay, outliers 47,000, 50,000, 66,000, 1 million. Oh my god, 1,677 characters. Okay, this is just wicked. And there are a couple of those. So let's set this to 40,000. English is going to be 40,000 threshold. And let's put a breakpoint and let's run this. Let's see what's up with English. Okay. First one, 152,000. Humble. Very humble. Wiki Matrix, of course. Just quickly paste it here, but we are definitely not going to delegate this to anyone. This is gonna be a long one. Okay, let's see what's up. Isolated, Lias, efficiency. This is some chemistry stuff or biology, enzymes and stuff. Some diseases. Okay. Let's see the next one. Hit F5. Here's the second one. Again, Wiki Matrix. Let's dump it here. Okay, just a ton of names. This looks like some alphabetically sorted weird string. Okay, let's go further. Let's just go and hit F5 to get to the next outlier. 66,000, this one. Again, looks like some weird list. Let's see. Born, just some repetitive gibberish text. A ton of gibberish text. Okay, let's continue. F5, find the next outlier. 97,000, this one. Okay. Again, looks like just some random data from Wikipedia listing some stuff. Names of animals or whatnot. Continue. F5. 50,000 links. Whoops. Let's see this one. So Sorry, let me just again copy paste this. Let's see what this is. Okay, again, weird. Alphabetically sorted list. Let's hit F5. Maybe only a couple more outliers. Data analysis, gotta love it. Nothing, we didn't find any outliers so far. Let's wait a bit more. Okay. $47,000 characters. Very large. Will we manage to open up 1.8 gigabyte file? Okay, let's go here. Guys, this is not even English. At least not the beginning. Let's paste this one. Okay, a ton of URLs. We can easily filter this out by just simple URL analysis or whatnot. Okay. Continue. F5. Let's find the next one. These ones are in TIL. Again, this looks like some Wikipedia bottom of the page text or something. Okay, my Google Doc is stuck, looks like. How long is this one? Oh, 1,600,000. I might have messed up my browser. This will not work. Okay. Wait a bit more. We should have not copied this. It's gonna be like hundreds of pages. Let's just see what's going on. Some hotel stuff, recommendations, categories, ladies beach. Okay, definitely not something we care about. How can I undo the operation? Just cancel the operation, not close the window. After you've clicked Control Paste, you are done. Oh my god. Can somebody calculate how many pages of text is 1,600,000 characters? Let's say that's about 300,000 words. That's gonna be thousands of pages probably of text. Why did I paste it before checking? I don't know. Let's just continue here while we're waiting for this to unblock. Same thing here, again, million. We're not gonna analyze the data. Let's see what's happening with our browser. Hopefully we didn't mess up everything else we collected. That would be very bad. Okay. Running in the background apparently. It's a long file. And it's a big file, 1.8 gigabytes for a single file. The scary part is most of our translation data is going to be mined. That's why it's, if we had a way to collect high quality translation data from some application or game or something, that would be amazing. That would be super cool. If you guys have any idea, let me know in the comments. What could we do to collect higher quality data? While this is running, we're blocked both in VS Code and Chrome. Let me see whether anything happened here in the server. Why are we still waiting here? It's really not that slow. Okay, it's progressing. Okay, here we are. We found the next outlier. Okay, this one is again 1,600,000. We're gonna ignore that one. Same here. Okay, let's check out this one, 47,000. Open anyway. 1.8 gigabytes. So this dataset is super big. This is the TIL dataset. Ton of data. Let's go to the line number of interest. I see the same line. We've seen this before already. That's just a ton of URLs. I think this was the last outlier for English. So the insight is most of this data is just mined data in particular data sets. Did this die? Okay, it worked. Can't sync the changes because we got to 500 pages, guys. This is the content. This is the content. Oh my God. Okay. I don't think we've lost anything other than English. Malayalam. I think Malayalam was the last one, right? Let's see. Let's go to the notes. Malayalam, and then we have these four. Okay, we're good, guys. Luckily, nothing happened. Go back to... Let me close down these files. close a ton of these files we opened up. Analyze data, almost ready with English. I don't think we have anything interesting in English. So we saw all of them are just either TIL or Wikimatrix or JW. Mostly looks like it's mine data, not actual translations. So yeah, that's it. We can stop the English. And now we can analyze maybe Russian. Let's go up there. Let's reduce this to 2000. Let's remove the breakpoint and let's put the breakpoint down there. Here. Save. Run. Let's see for Russian. This one might also take some time. Oh, actually not. It's fairly fast. Okay, interesting. I thought Russian is very has a lot of sentences as well. Apparently I was wrong. I'll have to run in a couple minutes. Let me just wrap this one up and see what insights can we take for Russian, and then we're almost done with our data analysis. Would be cool to do some duplicate analysis as well, just to understand which data sets contain a ton of duplicates. Let me open up this. Okay. I kind of see the whole pipeline in a couple of components. So the first one is data collection. If we're doing mining, that's a separate beast. For now, we can treat it as a black box. We just get the output artifact in the form of the mine data from the LNAI folks, 450 gigabytes of data. We also have these public data sets. So that's kind of the first component, getting the data. The second one is analyzing, understanding the quality of the data, the line lengths, the duplicates, the quality, everything. So that's what we're doing now. Then the third component is going to be filtering. The fourth one is the prepare data stage, where we do sharding, binarization, all of that. And so there was a fourth one. And then once we are done with that, we have the training, which is the fifth one. So there is a couple of components across the spectrum here. So for Russian 21,000, mostly these seem like duplicates, all of these. So we can set it to 20,000. I'm going to stop now because I have to run. But we can continue the stream a bit later. 20,000 is the right threshold. Maybe just let's see a single sentence and then we can go. Let's just see a single Russian sentence. It seems most of them are in a couple of files. Looking at how fast we went through these, and then we are now slow. Okay. Come on, come on. Waiting for the Russian sentence to hit the breakpoint or the outlier above 20,000 characters. English equivalent characters, because we do have that multiplication by the length factor for the language. Okay, progressing, progressing, progressing. Okay, first one. Okay, let's go to this file. 20,000. Definitely looks like Russian language. Let's open up this. Russian. Okay, we'll keep on analyzing it later. But this is the first piece of text in Russian. Guys, catch you later. I'll announce when the next stream is starting. Let me just think for a second. Thanks, Pierrot. So this one, I'll be there 1:30, 3, 4, 5, probably likely around, let's say 4 or 5 p.m. more likely. Roughly, that's when I'll start the next stream. That's Central European time zone, CET. You can convert it to your local time zone, and then you can see more about that. And also I'll be just notifying you in the channel. So if you haven't joined the Discord server, join the Open NLLB channel. That's the best place to get information, stay up to date with the project. Ton of new people joining. Some of them have been working in machine translation area for like two years or more. And so join us. Cheers, guys. Have a nice day. Have a nice evening wherever you are until 5 p.m.